The Euclid Dark Matter and Energy Telescope has sent back the first images. Launched a month ago, the Euclid telescope reached its final destination at the second Lagrangian point. The observatory, which aims to shed light on dark matter and energy, took its first images during its startup phase. According to ESA specialists, these test photos already show that Euclid will be able to fulfill the hopes placed in it. The Euclid mission to study dark matter and dark energy was launched into space on July 1. During this time, the observatory traveled to the second libration point, also known as the second Lagrange point, which is where the James Webb Space Telescope has been located since January 2022. It is a place where the gravitational interactions of two bodies, in this case, the Sun and the Earth, cancel each other out, so objects located there can remain almost motionless, which greatly facilitates observations. The main goal of the mission is to understand the nature of dark energy and dark matter by accurately measuring the accelerated expansion of the universe by various independent methods. Recently, mission controllers from the European Space Agency, ESA, released the first images taken by the Euclid telescope. The star-filled images were taken during the telescope's commissioning phase, a phase in which the powerful instruments on board the satellite are precisely calibrated, and therefore do not reflect the observatory's full potential. After more than 11 years of designing and developing the Euclid mission, seeing these first images is exciting and incredibly emotional, said Euclid project manager Giuseppe Racca. The images sent by the telescope to Earth show that the Space Telescope will achieve the science goals for which it was designed, and possibly much more. While it will still be some time before the observatory reaches its full capacity, the first images show that Euclid survived the journey in good condition and all the science instruments on board the telescope are working well. When we think that we only see a few galaxies in the images, and these were taken with minimal system tuning, it's even more unbelievable. The fully calibrated Euclid will eventually observe billions of galaxies to create the largest 3D map of the sky to date, Racca said. The image taken with the NISP instrument reveals a dazzling starscape of billions of stars and galaxies. Before reaching the instrument's detector, light from distant objects passes through a special filter that splits the light from each star and galaxy according to wavelength, allowing allowing astronomers to determine what each object is made of and how far away it is. The first launch of the VIS instrument scared the researchers a bit. They saw light pollution on it, which they did not expect. Further inspection revealed that some light was entering the telescope, possibly through a small slit. Fortunately, it turned out that light pollution is detected only in a specific orientation of the observatory, so by avoiding this orientation VIS will be able to fulfill its mission. The photo below was taken in an orientation where sunlight was not a problem. The Euclid telescope has a main mirror with a diameter of 1.2 meters and is designed for observations in the band from visible light to near-infrared. It has a visible light camera called VIS, a near-infrared spectrometer, and a photometer to determine the redshift of detected galaxies, NISP. The observation area is to cover as much as 15,000 square degrees, which is over 1/3 of the entire sky. For comparison, the full moon occupies about 1/5 of a square degree in the sky. The Euclid telescope weighs 2 tons and its dimensions are 4.7 meters high and 3.5 meters wide. The mission is a huge collaborative project. The consortium that proposed it alone consists of over 2,000 scientists and engineers from 15 countries. Its cost is approximately €1.5 billion. The VIS camera is one of the largest ever sent into space. It will take high-resolution panoramic images of a large area of the universe, stretching back 10 billion years and covering 1/3 of the night sky. Using this data, astronomers will measure the shapes of 2 billion galaxies and use a technique called gravitational lensing, observing how light from distant galaxies has been bent by the gravity of matter in the telescope's line of sight, to infer the large-scale distribution of visible and dark matter more accurately than previously possible before. Since observing distant galaxies allows us to go back in time, astronomers will be able to analyze how dark matter evolved. This will provide insight into the interactions between dark matter, which binds galaxies together, and dark energy, which pushes them apart. Based on the measurements of the Euclid mission, a 3-dimensional map of the universe will be created, which will cover an area extending 10 billion light-years from our planet. There are about 2 billion galaxies in this area, which, thanks to scientific equipment, will help to better understand and gain more detailed insight into the approximately 13.8 billion year history of the universe. everything we can see in the world around us, stars, galaxies, flowers or our bodies, accounts for only 5% of what we see. The mass of the universe. This so-called baryonic matter. The rest, according to leading cosmological theories, consists of two elements: dark matter and dark energy. Their existence is inferred indirectly, because these hypothetical substances are invisible, do not emit or reflect light radiation, and therefore are very difficult to detect. But their existence is betrayed by gravitational effects. At least that's how scientists explain anomalies in the rotation of galaxies and the movement of galaxies in clusters. There is too little visible matter to explain the effects in these cases. Dark matter is thought to hold galaxies together and act as the glue that holds them together. Dark energy, on the other hand, researchers believe is accelerating the expansion of the universe. That is, the leading cosmological theories treat dark matter as an element that slows down the expansion of the universe, and dark energy as something that constantly accelerates it. However, despite years of searching, the existence of dark matter and energy has not been confirmed. Scientists are still trying to figure out what their exact nature is. The Euclid mission is about to change that. Over the next few months, ESA scientists, along with partners from other institutions, will continue to run all the tests and checks necessary to ensure that Euclid is performing at its best. At the end of the commissioning and validation phase, the real testing will begin. ESA will certainly release a new set of images at that time to show what the telescope is capable of.